So you're probably used to seeing equations y equals mx plus b.
Yep.
Yeah. Do you know what the m stands for?
The slope.
Yeah. So m is your slope, which is also equal to what? Do you know? Two r's.
Rise or run.
Yeah, that's right. Good. So you got your rise over your run, and do you know what the b stands for?
The starting point.
Where's that starting point though? Specifically, do you know what it's called?
What is that?
Starts with y, which isn't very helpful because it's called the y and then it's
Axis. Wait.
yeah. So it's on the y-axis, but they call it the Y-intercept.
Oh, okay.
Okay. So this is called the Y-intercept. I'm going to show you what they mean by that. So let's get a graph going here. Actually. Okay, so we have our graph and numbered it 1 to 10. Okay, positive and negative. The Y-intercept, you're right. Y-intercept refers to the y-axis. I'm going to shrink this graph a little just so we can see it. So y-intercept deals with our y-axis, which is up and down. This is our x-axis. Okay, and the y-intercept is the point along the line we're going to draw. We're going to draw some line, could look like this, who knows, could be any of those things, right? The y-intercept is where the line hits the y-axis. So all of these have different y-intercepts, okay? So in the equation, that's why they will possibly have different numbers. So I'm just going to create one. Our equation, let's say, is y is equal to 2 over 3x minus 3. Okay? So first thing we got to figure out is the y-intercept. So your y-intercept is what?
-3.
That's good. So when I go to the graph, I go along the y-axis down to -3.
Okay.
That's where it's going to cross. Okay? From there, do you know what I do? What would I do?
You go 3 right, then 2 up.
It's good. How come I go right and not left?
Because positive.
So it's positive. Good. So I go over 3, up 2. Over 3, up 2. And we got our points, and then from there, what do I do?
You go down.
Okay. How would I go down?
-3 that way, then -2 down.
Good. All right. So you can reverse it. Why can you use -3 and -2? So let's say we have, our slope is 2 over 3, right? Why does -3? Why does -2, and -3 work? Any ideas?
Because they're both, no.
Because these are both positive, right?
Yeah.
Do you ever remember integer rules? What's a positive divided by a positive? What do you get?
Positive.
Positive. What's a negative divided by a negative?
Positive.
Positive. So actually what this says, -2 over 3, is that. It's the exact same thing. So when we do it, we go -2 over 3 is actually equal, so -2 divided by -3, it's actually equal to +2 over +3, okay? That's why, because when we divide them, they both end up as positive answers. So that's why we're allowed to go back the other way, okay? And then, guess what? Back to kindergarten. We get to connect the dots. Oh, shoot. It's going a little slow. So I'm going to give up there, and I'll take a minute. All right? So that's simply graphing it. That makes sense?
Yep.
Now let's say they've given us two linear systems, because this is all about finding points of intersection, or solving a linear system. You've heard that before?
Yeah.
Yeah, so that's what they'll talk about when you're doing this chapter. So let's say I get another one.
Then you have to find the point of intersection?
Yeah, very good. So let's say we have y 3x no. What did we do here? Sorry, I want -3. I'm just trying to think of a good one that'll give you a whole number. That looks right. And +1. Okay. So say we have this equation now. Where's my y-intercept in this equation?
Pardon?
Which of these two numbers is the y-intercept?
Oh, the 1.
The 1. So we go over to it. 1. What about -3? What does that represent?
The slope.
Okay, so how does that help me with slope? What do I do from this y-intercept?
-3. So you'll go 3 times left.
3 to the left?
Yeah.
Why is that?
That's right. Sorry.
That's okay.
One's to the right, then 3 times up.
Is it up or? You know what I'll do? I'll help you out here. So this here, -3, is a whole number, but I can turn
Pull it down.
any whole number, I can turn it into a fraction. Okay, so if I have -3, I can turn it into a fraction by just putting it above 1.
Yeah.
If I had the number 5, it could be a fraction by just putting it above 1. Okay, so now that I have -3 over 1, remember slope is equal to rise over run. Okay, so our rise is to what? Go.
Right. Up or down?
Yeah, okay, and in this case it's -3, so which direction do I go?
Down.
Down. Good, so I go down 1, 2, 3, and then our run is +1, so which way do I go? Right one. So I go right there. So here are points 1, 2, 3, down 1, 1, 2, 3 to the right one. And we go to connect these dots. Hopefully it doesn't go slow like the other one. Okay, and we go to connect those dots. We get our point of intersection. Okay, what's important to remember, and so in your question,
How do you do it up? How do you do it up? Because our teacher wants us to extend all the way.
oh, how would you go up?
Right? Same.
Okay, so here's a good question. So, say we have -3 over 1. Remember I told you +2 divided by +3 was the same as the other way? We can flip this fraction. Sorry, we can't flip it, but we can flip the negative sign on it. So we have -3 over 1. That's also equal to +3 over -1. Yeah, those are still the same. Whether you put a negative on the top or the bottom of the fraction, it's still going to be a negative because our rule is, remember this sign in between, that's a division sign. So this is a negative number divided by a positive, which is going to make a negative. And here we have a positive divided by a negative, which is going to be a
Negative.
Yeah. So to go the other way, instead of going down 3 into the right one, we go up 3, 1, 2, 3, and back 1. Up 3, 1, 2, 3, and back 1. Right? Which makes sense with our +3 divided by -1. Okay? So then when I go to extend it all the way to here. It's going to go a bit slow. That's it. That's how we would extend it. Okay? So you just flip the slope of that. Whenever you have a linear equation, we use 2 over 3x minus 3, so I'm going to bring that down. 2 over 3x minus 3. So these were the two equations, equation 1 and equation 2.
Yeah.
Whenever you have a slope, which is our number in front of the x, always turn it into a fraction. So if it's a whole number, just put it above 1, and if it's already a fraction, leave it. Because it's way easier to do slope if you have it in fraction form, because we know the top number is the rise, and the bottom number is the run. Does that make sense? So always turn slope into a fraction. So I'm going to get you to try these two here. Okay? And turn around and grab you a piece of. Okay. Next thing we're going to do is substitution. We have these two equations, and we're going to number them. Okay? I have equation 1 and equation 2. Now what's important is I have to set one of the equations, either 1 or 2, doesn't matter, equal to a variable. So I set equation 1 equal to y, or I set it equal to x, or I set equation 2 equal to x or y. Now, I probably should have chosen that one, but if you look at equation 1, it's already set equal to a variable. What variable is it set equal to? Y. That's right. This one says y is equal to all of this. So actually, you've already done a step for me. Just to make it more realistic of what you'll probably have to do, I'm actually going to start with equation 2. Which variable do you want to set it equal to, either x or y? You know what? That's giving us fractions. Let's start with this. That way you can leave the fractions till the end, okay? So we know that y is equal to -2x plus 2. So I'm going to take that and I'm going to plug it into equation 2. So I'm going to rewrite equation 2. Equation 2 is 3x plus 2y equals 5. Okay. And now I know that y is equal to this, so I'm actually going to substitute in for just y. Okay, so I'm going to put that in there. So I get 3x plus 2, and then I get rid of the y, and I put in -2x plus 2 is equal to 5. Does this make sense so far?
Yeah.
What do you do with the 2 then?
Multiply the -2x.
Yeah, so what am I going to end up with?
Plus -24. No, -4
is negative 4 plus 4?
Sorry, negative 4x.
Good.
Plus 4.
Is equal to
5.
And then what would be the next step?
Collect the return.
Okay, what would that?
Would be negative x. No, negative x.
Yep.
Equals to 1.
Very good. So you brought the 4 over and subtracted. Can I leave it like that? Negative x?
No.
What do I got to change it to?
X equals negative 1.
X equals negative 1. Very good. All right, am I finished?
Yeah.
That's it? Answer is x equals negative 1?
No, then you have to figure out y.
Okay.
You have to get y.
So how would I do that?
Substitute for equation 2. You can do either one, right?
Yeah. Good.
So
Which one do you want to use?
I use the 2.
You want to use equation 2?
Yeah.
Again? Okay. So I'm going to use equation 2 again. 3x plus 2y equals 5.
Then 3x. No, 3 and then brackets 1.
Just 1?
Yeah, right. Because you're substituting it in.
Yeah.
Negative 1.
There you go. Good. So I get 3 bracket negative 1 plus 2y equals 5. What's next?
Negative 3 plus 2y equals 5.
Good.
Then 2y equals 2. Y equals... Wait. Yeah, no, sorry. 2y equals 8.
Good. When I bring the 3 over, it becomes positive.
Yeah. Sorry.
I know it's good to skip steps because you want to move fast, but make sure you do them right. If that step there would have took you like 2 seconds to do, and it would have ensured you're right. So don't be afraid on a test, especially because usually they'll give you a good amount of time to actually put that step in. 5 plus 3 takes a second to write, and then boom, we know it's 8. That way I can look back to check. Okay?
Then y equals 4.
Yeah, that's right. We divide by 2. There you go. Y equals 4. So what is my point of intersection if they told me to write it as a coordinate, right? They want as a coordinate my x and my y value.
Negative 1, 4.
Substitution's easy?
Yeah.
All right. Okay, so the very first step that we didn't have to do in the other one, we're going to have to do here for substitution is I actually have to set the equation. Right now, this equation is equal to 8. This one's equal to 5. I actually have to set it equal to either x or y, either of the two. Okay? So let's say we choose equation 1. Which variable would you like to set it equal to?
X.
Okay, so if we're going to set it equal to x, we have our 2x minus 3y equals 8. Okay, that means I got to get x by itself. So my first step is I'm going to move the negative 3y to the other side of the equation. So what will I have? I'm going to have
3y plus 8.
Yeah, so 8 plus 3y. And on this side, I'll still have 2x.
Oh, it wouldn't be the other way around?
Doesn't matter. You could write it like that too. 2x equals 3y plus 8.
Okay.
Because 8's positive. That's fine. You can rearrange the order as long as you just keep the sign in front. Okay. But I gotta isolate for just x. So how do I move that 2 over now?
You isolate everything. You divide everything by 2.
Yeah. So whatever I do to one side, so I divide this by 2.
Okay.
I gotta divide all the other terms on the other side. So I know this is a separate equation, but I'll do it just so you see that you end up with the same answer.
Wait, how do you know that they're going to become a fraction?
How did I know?
Yeah.
Because I've done this so many times. So, the 2's cancel out. Okay. And we're going to end up with x is equal to, what's 8 divided?
4 plus
Mhm.
3y over 2.
Yep, 3y over 2. Or, another way to write it, x is equal to, now we're used to writing, when we're doing linear equations, it's not a bad idea to actually put 3 over 2y plus 8. Okay? This way,
Okay.
if they're asked to graph, this looks a little more like what we're used to seeing when it's y equals, yeah, exactly, okay? So anyways, there's the important part. Now that I've done that, I know that x is equal to this. So this is equation 1. So I have to plug equation 1 into equation 2. I can't plug this back into equation 1. Okay? So make sure your next step is to go to equation 2, write out 6x plus y equals 5. Okay? And we know that x is equal to that, so I'm replacing the x in the other equation with that. So I get 6 times 4 plus 3 over 2y plus y equals 5. sense? Okay. And then the rest of the steps are the same from there on in. Okay, so give that one. All right, so the next step would be to distribute, right? Let's get this better view here. Okay. So our next step is technically I got to take this 6 and multiply it by both numbers in the brackets. 6 times 4 is 24. Here I end up as a fraction, so I'm going to do it on the side in red, okay? So 6 times 3 over 2. The y is just going to stay the y. We're just changing the coefficient, which is the number in front of the variable.
Yeah.
Remember I told you can make any whole number a fraction? How would I make that a fraction?
Would you do 6 times 2?
Not quite. How do I make just 6 itself a
Oh,
fraction?
I get it. Oh, 6 over 1.
Yeah, that's right. So now I'm multiplying fractions, okay? Always make a whole number into a fraction. Anytime we're going to multiply, add, divide by them. So now our fraction rules. I have 6 over 1 times 3 over 2. When we multiply fractions, we do the top numbers by each other and the bottom numbers by each other, okay? So 6 times 3, 18. 2 times 1, 2. All right. And what does that become?
9 over 1. Oh, 9.
Yeah, exactly. 9 over 1, that's right, which is the exact same as writing the number 9. Okay? So when we multiply it in here, we ended up with actually plus 9y. Plus y equals 5. So that actually turned out nicely, that number. Okay? So give it a try in your question. All right, let's say we get to this step here and we have a coefficient larger than 1, so we have 3x is equal to some fraction. And we can't reduce a fraction without making it a decimal. Okay. Now, technically, this tells us we need to isolate for x. So what would I normally have to do? I have to divide, right? I got to divide by 3. Dividing, see how we write it as a fraction here? Can also be written like this, divided by 3. Okay. So when we divide by 3 on the left side, we're going to be left with just x. X is equal to, we still got to carry out this step. 8 over 3 divided by 3. Now, can I make 3 a fraction?
Yeah.
What is it?
3 over 1.
Okay. Do you remember division rules for fractions?
Yeah. Do you have to flip?
Invert and one other step to it.
You have to turn into the opposite sign.
Yeah. So what does it become?
Wouldn't it be times?
Yep. So we get 8 over 3
Times 1 over 3.
8. And what does that become?
8 and 9.
So x is equal to 8 over 9. Now, if you want to know a shortcut, now remember this. This was the important part. This part we just did here. That's very important. If you got that down pat, a quick trick is if you get like 3x is equal to 8 over 3, I know quickly in my head, I can rewrite this as x when I have to divide by 3. It's equal to 8 over 3 times 3. All right?
Yeah.
I can just do that quickly, and then I'm going to end up with 8 over 9. Okay?
Wait,
But
did you do 3 times 3 because of that?
because we're bringing the 3, yeah, because this is 3, I'm bringing the 3 technically to the bottom. You know how we normally, when we do it, we do divide it by 3?
Yeah.
Well, because there's already 3 there, I got to multiply by whatever's there. So if it was a 9, I would have had to multiply 9 by that 3 which I brought over. Okay, so whatever you bring over, just multiply to the bottom of the fraction. Does that make sense?
Yeah.
If you can't remember that step, do it the long way because it's the safe way, and you'll get the full marks for it. Okay, so give it a try there. All right, elimination. Okay, so we have our 2 equations here. In elimination, we can choose whether to add or subtract. It's completely up to you. So actually, when I look at this, right away I notice that our coefficients of 2x and 2x, the 2's are the same. So as soon as your coefficients are the same, that's the number in front of the variable, I know I can eliminate. I just got to choose what sign am I going to use. If I add them together, positive 2x plus positive 2x is going to give me 4x. So it doesn't eliminate. But if I were to subtract the 2 equations, positive 2x subtract positive 2x is going to give me, it's eliminated. Essentially it gives me, because 2 is 0, x, and what's 0 times x? 0. So it eliminates itself, so we don't need to put it in. Okay. The next step, I have positive 5 minus negative what number? 1. Okay.
This 6.
Yeah, very good. So you know how to do integer stuff quickly? I'm going to write it on the side.
2 negative, make it positive.
Very good. I'm glad they've taught you that. So we have 5, subtract a negative 1. You can simplify that by just doing 5 plus 1 equals 6. Good. Glad you know that. So we get 6y is equal to, and then we have 3, subtract negative 3. So y equals,
So, no, 1.
good. All right, so I eliminated that way. Let's do the exact same equations. Now, I bet your teacher's probably told you after this step, are you allowed to substitute back in?
Yeah.
Okay. I make my guys eliminate the other numbers this time. So I'm just going to cheat you it just because it's a little different this time. Equation 1.
Substitute other numbers.
What's that?
What do you mean substitute the other numbers?
Not substitute, sorry, eliminate the other numbers. So from here, because we know what one of the numbers is, I can just plug it into this equation or into this equation to solve for my x, okay? But because I want you to get good at elimination, I want you to actually eliminate the y's now and solve for x instead of using that substitution. So this time what we're going to try to do is we're going to try to eliminate the y's. So I need to make the coefficients the same in front of the y's.
Multiply everything by 5. Right?
Okay, which equation?
It's 2.
Equation 2, that's right. If I multiply everything in that equation by 5,
Wouldn't it be negative 5?
it's okay, it'll still work. So let's talk about it. This one is going to, anything change in equation 1?
No.
No. So we get 2x plus 5y equals 3. What about equation 2?
10x.
Yep.
Negative 5.
Yep.
Equals negative 15.
Great. All right, so we got that now. Now, the coefficients, the 5's are the same, but one's positive and one's negative. How can I eliminate those if I do what to the equation? I have two options. I can either add the equations together or subtract them. If I subtract the two, will positive 5 subtract negative 5 eliminate them?
No.
No. What will it make?
10y.
Yeah, okay. What if I do the other option? What's the other option? Instead of subtracting, what if I add them together?
Yeah.
That will eliminate them, right? So let's add the two equations together. So when I add positive 5 plus negative 5, what happens to the y's?
Cancel.
They cancel out. So they're gone. What is 2x plus 10x?
8. Sorry, 12.
Yeah, there you go. Make sure you remember what sign you're using, okay?
Oh, but wait, wouldn't it be 2 negative 10x?
Why would it be negative?
Isn't it always negative?
You can choose. Maybe your teachers told you only to use subtraction. You can choose whether to use subtraction or addition.
Oh.
It's whatever one is going to eliminate them. So maybe your teacher, we'll do this on the side quickly, because I know some teachers do like things differently. You see how you multiplied by 5, and then technically you were right. You picked it out that this was going to be negative 5. If your teacher only wants you to subtract, you would have actually had to multiply, and we'll call this the version where you multiplied by negative 5, okay? That way, if you multiply by negative 5, your new numbers, we'll write them in green, would have been for equation 2, negative 10x, you're right, plus 5y, and plus 15, or positive 15. Does that make sense?
Yeah.
If we multiply by it? Then in that case, to eliminate the y's, what would you have to do to the two equations? Because they're both positive, what operation would I have to use to eliminate them?
Subtraction.
Subtraction, which is what your teacher liked, right?
Yeah.
So positive 5 subtract positive 5
Cancel.
cancels, okay? And then what's 2 subtract positive 10?
12x.
Hey, notice anything similar?
Mhm.
You want the same, right? What about 3 subtract 15?
12, right?
Close. 12's right. 3 subtract 15.
Was it
3 subtract 15.
3, 12? No, negative 12.
Yeah, that's it. Negative 12. Okay. So that'll be a negative. I'm just going to erase this part so we don't get confused later. Okay. And when we look at this, 3 plus negative 15, what does that give us?
18. Sorry, 12. Negative 12.
Negative 12. Notice we're getting the exact same answers?
Mm-hmm.
Okay. So if you notice, it didn't matter if we added or subtracted. We just had to use whatever operation was going to eliminate those variables. That's what's key, okay? If your teacher wants you to subtract, then always make the coefficients have the exact same sign, okay? Do that. And in the end, we get 12x equals negative 12. What's x going to be?
X equals 12.
Well,
Sorry, x equals negative 1.
yeah, there you go. So 12x equals negative 12. X equals negative 1. So we got the exact same answer whether we add or subtract. Okay. So always remember that. And then our point of intersection for our elimination was -1, and what was our y? 1. So that was our point of intersection. Okay. Does that kind of make sense?
Yeah.
Okay. Why don't you give